In this question, we have to show that the straight lines whose direction cosines are given by the equation ul plus vm plus wn equal to 0 and al square plus bm square plus cn square equal to 0 are perpendicular if u square bracket b plus c plus v square bracket c plus a plus w square bracket a plus b equal to 0 and are parallel if u square upon a plus v square upon b plus w square upon c equal to 0. Here the direction cosines of two straight lines are connected by the relations ul plus vm plus wn equal to 0 and al square plus bm square plus cn square equal to 0. And we have to find the condition if two lines are perpendicular and if two lines are parallel. So first we write here the relations ul plus vm plus wn equal to 0 and al square plus bm square plus cn square equal to 0. Now we eliminate n between first and second. So eliminate n between first and second. So from first we can write here n is equal to minus times ul plus vm divided by w. So this is the third equation. Now we eliminate n between second and third. So we put here value of n in equation second. So this can be written as al square plus bm square plus c times and minus times ul plus vm divided by w whole square equal to 0. Now we can write this al square plus bm square and here minus square is plus, this is c upon w square and here we use formula a plus b whole square. So expanding this we can write u square l square plus v square m square plus 2 u v l m equal to 0. Now we multiply this whole equation by w square. So this can be written as a w square l square plus b w square m square plus open this bracket c multiply all these three terms. So c u square l square plus c v square m square plus 2c u v l m equal to 0. Now we form this equation in quadratic. So we can write this equation as a w square plus c v square m square a w square plus c u square l square plus 2c u v l m plus this is b w square plus c v square m square equal to 0. Here you can see here a w square plus c u square l square plus 2c u v l m plus b w square plus c v square m square is equal to 0. Now we divide this whole equation by m square. So we get a w square plus c u square l square by m square plus 2c u v l by m plus b w square plus c v square equal to 0. So this equation can be written as AW square plus CU square multiplied by L by M whole square plus 2CUV multiplied by L by M plus BW square plus CV square equal to 0. This is the quadratic equation in L by M. Let us suppose that let L1 upon N1 and L2 upon M2 be the roots of above equation. So product of the roots is L1 upon M1 multiplied by L2 upon M2. This is equal to C upon A, that is the constant term, divided by the coefficient of L by M whole square. So this can be written as BW square plus CV square divided by AW square plus CU square. If we can see here, this is the quadratic equation in L by M. So we suppose that L1 upon M1 and L2 upon M2 be the roots of this equation. Now we find the product of the roots of this equation, L1 upon M1 multiplied by L2 upon M2. This is equal to constant term, that is BW square plus CV square divided by the coefficient of L by M whole square, which is AW square plus CU square. So this can be written as L1 upon L2 upon BW square plus CV square is equal to M1 M2 divided by AW square plus we write here CU square plus AW square. So by symmetry we can write here value of N1 and N2 divided by, here we can see that suppose we write here A, B, C and here U square, V square, W square. So in first term we can see here this is BW square plus CV square. In the second term here CU square multiplied by AW square. In the third term we can see here this is AV square plus BU square. So we write here AV square plus BU square. So here we write AV square plus BU square. Now since we have to find here condition if the two lines are parallel and perpendicular. So first, if lines are perpendicular, then we know that L1 L2 plus M1 M2 plus N1 N2, this is equal to 0. Now we put here value of L1 L2 and M1 M2 and N1 N2 from the above ratio. So we can write here L1 L2, this is equal to BW square plus CV square plus CU square plus AW square plus AV square plus BU square, this is equal to 0. Now we taking common here U square term from these two terms. So we get here B plus C U square. Now we taking common here V square, that is C plus A here, C plus A V square, and now we taking common W square from these two terms. So we write here A plus B W square. So this is the condition if two lines are perpendicular. Now we find the condition if two lines are parallel. So if lines are parallel, then if lines are parallel, so we know that if lines are parallel, so we can write if lines are parallel, so we know that if lines are parallel, then direction cosines of both lines are equal. That is, L1 is equal to L2, M1 is equal to M2, and N1 is equal to N2. If the two lines are parallel, then the direction cosines of both lines are equal. That is, L1 is equal to L2, M1 is equal to M2, and N1 is equal to N2. So, if the direction cosines are same, so the roots of this quadratic equation are also same. So if lines are parallel, then direction cosines of both lines are equal. That is, L1 is equal to L2, M1 is equal to M2, N1 is equal to N2. So the roots of above equation 1 are also equal. And we know that the conditions for both roots are equal is b square is equal to 4ac. This is the condition if the roots of the quadratic equations are equal. So b is the coefficient of L upon m, that is 2cuv whole square, and a is the coefficient of L by m whole square, that is a w square plus cu square, and c is the constant term here, that is b w square plus c v square. Now we can see here 2cuv whole square, this is 4 c square u square v square, and this is 4. Now we multiply this ab w square plus cu square plus we multiply this a w square by b w square, so we get here we multiply this a b w square multiplied by w to the power 4 plus a w square multiplied by c, this is a c v square w square plus this is b c u square w square plus c square u square v square. Now we can see that this 4 is cancelled out, so this c square u square v square is also cancelled by this c square u square v square. Now we can write here a b w to the power 4 plus ac v square w square plus bc u square w square, this is equal to 0. Now we divide whole equation by abc u square v square w square. So we get here divide by a b c u square v square w square. So we get, when we divide this first term by a b c u square v square w square, so we get here w square. Now we divide this equation by abc and w square. So we get here this is w square upon c, and here when we divide by abc w square, so this ac and w square is cancelled out, and this is v square upon b. When we divide this third term by abc w square, so bc and w square is cancelled out, and we get u square upon a equal to 0. So this is the condition u square upon a plus v square upon b plus w square upon c, that the two given lines are parallel. Thank you.